In this video, I'm going to talk about the conditional probability, right? So you remember that in the last video, we were talking about if two events are dependent, right? So if two events are dependent, then if A and B are dependent, then probability of A and B equals to PA times PB, given that the first one is A, right? Probability of A in the first, and then times probability of B in the second, given that the A happened already in the first. So this is called the conditional probability, meaning the probability of B given that A already happened or A already occurred. So if you divide both sides by PA, then what you get is you cancel out that. So PB given A, that means probability of B given that A already happened is probability of A and B divided by probability of A. This is the conditional probability formula. Okay. So probability of B given that A already occurred in the first place. Okay. Let us do example number 10. A box contains black chips and white chips. A person selects two chips without replacement. So all these formula are for the dependent events. Okay, that's why. So a person selects two chips without replacement means the events are dependent. If the probability of selecting a black chip and a white chip is 15 over 56, what is given? Probability of black chip and the white chip is 15 over 56. This is given. And the probability of selecting a black chip on the first, probability of black chip on the first is 3 over 8. What is asked is find the probability of selecting the white chip on the second, probability of white chip on the second, given that the first was black chip, given that W, probability of W given that B or the black already happened or black already occurred is what? This is asked. So how do I use the formula? What is the probability of W given B? Is just probability of B given A is A and B. That means W and B divided by what goes under the denominator is after the slash. Okay, you see? What goes in the denominator here is the B, because you see in the formula, probability of B given A, the given things go on the denominator. And on the top it is B and A or A and B, whatever. It's okay. So probability of B and W over probability of B, right? What is given is after the slash that goes in the denominator. So what is the probability of B and W? It is given as 15 over 56. 56 whole divided by 3 over 8. If you simplify, what you get is basically you will get, I think it will be 5 over 7. That's what you get. Because how do you find out that? Is 15 over 56 times 8 over 3, right? So you get 3 times 5 is 15, 8 times 7 is 56. So you can write 5 over 7 is the final answer. Alright, let us do example number 11. So example 11 is the probability that the Sam parks in a no parking zone and gets a parking ticket is 0.06, and the probability that the Sam cannot find a legal parking space and has to park in a no parking zone is 0.20. On Tuesday, Sam arrives at school and has to park in a no parking zone. Let's say getting a ticket is denoted by T, gets ticket, and then park in a no parking zone, let's say denoted by PN, is the park in no parking zone, is park in no parking zone is denoted by PN. So let us list what is given and what is asked. Probability that Sam parks in no parking zone and gets ticket is 0.06. Okay, this is given. And another thing is the probability that Sam cannot find legal parking space and has to park. So what is the probability that Sam parks in a no parking zone? Is equals to 0.20. Now on Tuesday, Sam arrives at school and has to park in a no parking zone. So Sam parking and no parking zone already. Find the probability that he gets the ticket. Find the probability of getting ticket given that he parking in no parking zone. Use the formula probability of Pn and T divided by probability of Pn, because what is given is goes in the denominator, right? So that value is given as 0.06 given divided by probability of Pn is 0.20. What do you get? You get basically 0.03. That is the final answer, because if you divide 0.06 by 0.20, you will get 0.03. Let us do this example. Okay. A recent survey asked 100 people if they thought women in the armed forces should be permitted to participate in the combat. The results of survey are shown. So male. So out of 100 people, they asked, there were 50 male and 50 female. They asked if women in the military should be permitted to participate in the combat. Okay. So on the male, 32 of the male out of 50 said yes, 18 said no. On the female, 8 says yes and 42 says no. Okay. Total is 50. There were total yes is 40, total no is 60. Okay, so everything is given. You don't have to find the total from the table because the total is given already. Now find this probability. So you need to find out the probability that, let's say Y stands for yes, N stands for no, F stands for female, and then M stands for male. Let us write down what is asked. Okay, find the probability that the respondent answered yes, probability of yes, given that the respondent was a female. That's what it is asking. What is the formula? Probability of F and Y divided by probability of F, right? So what is the probability of F and Y? It is the probability, okay? Probability of female and yes. So 8 out of 100, because the total is 100, right? Since it is the probability, then we need to do 8 is F and Y divided by the total is 8 over 100. Now probability of female, how many are there female? That's 50 over 100, right? 50 over 100, because it is the probability, so 50 divided by the total. Now if you divide that, you will get, this is 50, you will get 8 over 50, that is same as 4 over 25. Okay, next, the respondent was a male, probability of male, given that the respondent answered no, probability of M given N, right? So what is the formula? Probability of N and M divided by probability of N. What is the probability of N and M? N and M is 18, right? So 18 over 100, because you need to divide by 100 because you are finding the probability, and you need to divide by the total there to find out the probability. Divide by probability of no. How many said no? 60. 60 over 100. So if you divide that, you will get 18 over 60, that will be 3 over 10. That is 0.03 in other words. Is there any other problem? That's all, right? Now example number 13. Let us look at this. A production process produces an item. On average, 14% of all items produced are defective. See, there is a company there, it produced the item, 14% are really defective, they are truly defective, and 86% must be good, right? Because out of the 100%, 14% are defective. But there is the thing, each item is inspected before being shipped, and the inspector misclassifies an item 8% of the time. What does that mean? Although 14% of the total item are defective, the inspector inspect 8% of them are good, right? And then 92% of them are defective, meaning 8% of the time they misclassified and 92% of the time they classified correctly. Okay. Similarly, on the good part also, that's the same thing. 8% of the time they are misclassified and 92% of the time they are correctly classified. Meaning, for the defective, 8% of the time they were classified as good or misclassified as good, and 92% of the time they were classified as defective. Similarly, for the good, 8% of the time they were misclassified as defective, and 92% of the time they were correctly classified as good. All right, let us look at the solution of this problem. Okay, so what it says is, in the inspection process, 14% of the items are defective. In the production, the 14% of the item are defective, and then 86% are good. And but when you inspect them, it doesn't matter whether they are inspected from defective or good, 8% of the time they are misclassified, meaning you may be misclassifying defective as a good, or you may be classifying good as defective. That is the 8% of the time. Okay, so the question is, what proportion of the items will be classified as good? So it is asking what proportion of the items are classified as good. Okay, so there are two ways you classify as a good. So one is the good item are correctly classified as good, and other is defective item as misclassified as good. Okay, so there are two ways. That's why let us look at the solution here. So here the probability of classified as good is probability of good times probability of correctly classified given they are good, right? And then plus probability of defective times probability of misclassified as good given that they are defective, right? That's what that's how we find out the classified as good. Okay, all right, so let's look at here probability of good is 0.86, probability of defective is 0.14, probability of defective and misclassified is probability of defective times probability of misclassified, that is 0.14 times 0.08, you will get 0.0112. This is because the misclassification is independent of good or defective, because misclassification is same on good and defective, right? So the misclassification is independent on good or defective. That's why you were able to multiply those two. Now in both misclassification is 8%. That is the reason why they are independent. Now probability of classified as good is probability of good times probability of correctly classified as good plus probability of defective and times probability of misclassified as good given they are defective, and you plug in those values. Probability of good is 0.86, probability of correctly classified as good is probability of correctly classified as good is 0.92, right? And then probability of defect is 0.144, and probability of misclassified as good, although they are defective, is 0.08. If you use that, you will get this value. Okay, so next thing you want to do is find the probability. What is the probability of an item? Find the probability that the item is defective given that it was classified as good. Item is defective given as it is classified as good. So what is the probability of that? It is probability of defective and misclassified as good. Defective and misclassified as good divided by the probability of classified as good, right? So what is the defective and misclassified as good? This is what it is, right? The probability is 0.0112. So that the top value is 0.0112, and the bottom value we got that already, that is 0.8025. Actually this value is called total probability. Okay, this value is called total probability. So the total probability we actually do not cover in this class. Okay, this is called the total probability. Total probability of classified as good. Okay, but we don't discuss that much only on this problem we discuss, but we don't discuss that much in the on this course. All right, and then whatever you get when you divide is the final answer there. Okay guys, thank you.